So this week in your assignment, you will perform a support vector machine analysis. I wanted to cover a little bit about what a support vector machine is and what is going on with the analysis. So I won't go too deep into the math behind the algorithm, but hopefully I can demonstrate kind of visually what is going on. So a support vector machine is a supervised approach to machine learning where we supply data or test cases for the algorithm to try to optimize the best solution. This model can be used for regression or classification. In the simplest form, if we have a set of data that we cannot draw a line between, we have to project that data into a new dimension that will allow us to separate that data with a line. So the basic concept is we are looking for the optimal separating hyperplane or line, if it's only in two dimensions, between two classes by maximizing the margin's closest points. The points on this line or this boundary are called support vectors. As an example used for this analysis, if we have a set of accounts like the Lending Club data, and we want to split those accounts into ones that will pay and those that will not pay, then we can use a support vector machine. We take in a set of data points about these accounts, and then we can use them to predict on another set of accounts that have unknown whether they're going to pay or not, to try to determine the likelihood that they're going to pay. So here's a set of data. How would you classify this data? We have some dots that are solid circles, and we have other dots that are hollow circles, right? So how could we classify this?
Well, it looks like it could be almost like two clusters.
Yeah. So we could use a line, right? Anything above that line would go into one classification, and anything below that line would go into the other classification. So very similar to logistical regression where 1 could be above the line and 0 is below. It's just a little bit different way of classifying the data. But which line do we use? Because that line splits the data, but does this line split the data better? Or that line? They all are capable of classifying the data, but how do we know which one is best? So there's a whole bunch of different possible lines to split this data. So what we first want to find is a margin of space between our data points. This is called the margin. And we increase that space until we touch a data point in both of the classes. So you see the orange colored kind of boundary? That is the classifying margin. And it's our boundary, and it just barely touches a solid point and a hollow point. So we want to find some linear classifier that maximizes this boundary, or creates the maximum margin. And this is called a support vector machine. In this case, it's a linear support vector machine because we're trying to use a line to separate the data. Those points that make up the edge of our boundary are called support vectors, hence why we call the algorithm a support vector machine. So all the points that touch the outer boundaries on both sides of this margin are the support vectors. So then we want to find the distance between a point, such as the point X in this diagram, and our line. how we can classify the data. So we want to make the boundary as wide as possible and maximize the distance of our line to each point. So this is kind of all the algorithms that are, or all the math that's going on behind the algorithm when we run it in R. So if we end up with data points that cause overlapping between our two cases, then we can adjust their weight to make them go into the correct case. That's kind of part of tuning your algorithm. If we cannot fit a line in the case of some nonlinear function, then we have to project it to a higher dimension so that we can apply some linear function. The technique that this is called quadratic optimization technique, and we solve a quadratic program with linear constraints. Here's another image showing how a support vector machine works. We want to maximize our margin or boundary with the best separating hyperplane or line. That's a line in 2 dimensions. And the support vectors are the points on the edge of our margin. In R, there's several packages we can use. In your book, it talks about KernLab and E1071. In your assignment, you're going to use E1071. The KernLab uses a different way of, it uses a kernel method for calculating this out, so it's a little different than what we're doing here. But it can be used in the KernLab can be used in nonlinear situations. We can calculate a confusion matrix like we did with logistic regression to give us our sensitivity, specificity, and other metrics, and that's what we can use to compare to other models, such as the models you're going to do in Assignment 3 and Assignment 4. Now, interpreting support vector machines is hard. There's still research going on right now to exactly what we can do with the coefficients that we get, because instead of like in logistic regression where we got parameter estimates for our coefficients, we get the actual support vectors weights, and they're working on how we can interpret those better. The major advantage of using a support vector machine, though, is that they're generally pretty accurate classifiers, especially compared to regression trees, which I talked about last week. So, I think that's all I have for support vector machines. Stop sharing. Do you have any other questions?
I didn't have any other questions. I did like the explanation with the margin and then the line, and then also with the support vector machine dots. So that was really helpful and insightful as well. So I appreciate that.
Okay, great. Well, when in your assignment, I just have like what code you type in and kind of how to do the analysis, but I just wanted to go over kind of what the analysis is actually doing.